Hello, my name is Bob Rucker, and this is a slide presentation on one of the most mysterious and potentially important artifacts in human possession, the Shroud of Turin. In the first 19 slides, I will explain what the shroud is, the images that can be seen on it, and other general issues related to the shroud. Then, starting with slide 20, I will discuss my hypothesis to explain the three main mysteries of the shroud: how the images were formed, the carbon dating of the shroud, and why the blood that would have dried on the body is now on the shroud. Further information regarding issues discussed in this video, as well as references, can be found in my paper number 32 on the research page of my website, www.shroudresearch.net. Shroud is spelled S-H-R-O-U-D. I'd like to first tell you about my background. I earned an MS degree in nuclear engineering from the University of Michigan. I then worked in the nuclear industry for 38 years, running nuclear analysis computer software for nuclear reactor design and for criticality safety for nuclear fuel production. I also worked for several years doing statistical analysis of measurement data. This experience has been used in my research on the shroud over the last 9 years. I've written 32 papers on the shroud that are available on the research page of my website, www.shroudresearch.net. My family and I also organized a conference on the shroud in the state of Washington in 2017. About 28 shroud researchers made presentations at this 4-day conference. They came from Italy, Spain, France, Mexico, Australia, and the United States, and about 200 to 300 people attended the conference. My goal in researching the shroud is to seek the truth by explaining the mysteries of the shroud. Scientific research on the shroud began in 1898 when an Italian attorney with a hobby of photography took the first photos of the shroud. When he developed his large glass plates, he discovered that the images on his plates were positive images instead of negative images. This proved the images on the shroud were negative images, with light and dark areas reversed. This indicated the images were not painted, since a painter would not be able to paint a good resolution negative image of a human face because, in that era, no painter would have seen one. This proves the images on the shroud were not painted. The shroud is a linen cloth measuring about 14 feet 5 inches long by 3 feet 7 inches wide, about 4.4 meters by 1.1 meters. In the ancient measurement unit of cubits, the shroud is 8 by 2 cubits. The top image shows how the shroud looks to the unaided eye. 2 horizontal scorch marks can be seen that resulted from a fire in 1532. In this event, the shroud was folded in a silver box and the fire scorched one side of the shroud. So when it was unfolded, it resulted in 2 scorch marks. The fire evidently also melted one corner of the silver box, which dripped down on one area of the folded shroud, so that when unfolded, it resulted in 16 burned areas. These burned areas were repaired in 1534, resulting in 16 patches. When the box was removed from the fire, water was thrown onto it, resulting in various water stains on the shroud. Fortunately, the important images can be seen between the 2 long scorch marks. The image of the front of the crucified man can be seen on the left side of the cloth, with his head toward the center of the cloth and his feet on the left side of the cloth. The image of the back of the crucified man can be seen on the right side of the cloth, with the head toward the center of the cloth and the feet on the right side of the cloth. The bottom image shows a photograph of the top image. This process causes the light and dark areas to be reversed. It also causes the right and left sides of the man to be reversed. The benefit of the photograph is that photography enhances the contrast so that the front and dorsal or back images of the crucified man can be seen more clearly. Notice there are no images of the sides of the body, and that the front and dorsal images are head to head. This painting from the mid-1500s shows why the front and dorsal images are head to head on the cloth. It also helps us realize that the front image on the cloth is a vertical projection upward from the body, and that the dorsal image on the cloth is a vertical projection downward from the body. The images on the shroud are of a man that was crucified exactly as the books of Matthew, Mark, Luke, and John in the New Testament describe that Jesus was crucified. The front image shows blood from puncture wounds in the scalp, a swollen cheek and bent nose, a 2-inch wide elliptical wound in the side just the size of a Roman thrusting spear, red and clear components running down from the side wound, scourge marks on the chest and legs, and abrasions with dirt in them on the nose and one knee, consistent with one or more falls. It also has blood running down the arms from the wrists, consistent with the arms being elevated above the shoulders, with the blood flow on the arms at 2 different angles, consistent with the man pushing up and down to breathe while crucified on the cross. The image shows a wound in the wrist rather than in the center of the palm, contrary to painting from the Middle Ages. According to experiments with cadavers, nails through the palms would not hold up a sufficient weight because there is no bone structure above that location. A nail through the indicated position in the wrist would crush the nerve that carries the electrical signals from the rest of the hand, causing the thumb to collapse into the palm. This is contrary to paintings from the Middle Ages, which usually have the thumbs prominently displayed. With the wound in the wrist and the thumbs not visible, the shroud gets it right, but paintings in the Middle Ages gets it wrong. It should be concluded from this that the shroud is not a product of the Middle Ages, contrary to the carbon dating of the shroud. Also shown is a 3.2-inch wide side strip running the length of the shroud. It is sewn onto the main shroud with a professional stitch that is unique, but most similar to a stitch found only at Masada, which was destroyed in 73 to 74 AD. This indicates the shroud is probably from the 1st century. The dorsal or back image on the shroud shows puncture wounds on the back of the head, abrasions on both shoulders, apparently from carrying a rough, heavy object, scourge marks with 3 dumbbell-shaped weights on the ends of leather straps on each flagrum, blood from the side wound that flowed across the small of the back, nails through the feet, and the shape of the feet indicating the presence of rigor mortis. This indicates he was dead long enough on the cross for rigor mortis to set in. Notice there is no indication either leg was broken, and there is no evidence of body decay on the shroud. Based on pollen from the Jerusalem area on the shroud, as well as small chips of Jerusalem limestone at the feet, it is generally believed the shroud was in Jerusalem, but must have been removed from the city before it was destroyed in 70 AD. It may have been taken to Antioch with other relics, and Galatians 3:1 indicates it may have been used by Paul for apologetic and evangelistic work in Turkey. It was probably taken to Edessa or Urfa, Turkey, before being taken to Constantinople, either in 574 AD as the image of God incarnate, or in 944 AD as the image of Edessa or Mendelian. The last reference to the shroud in Constantinople was in 1204 AD, at the time of the Fourth Crusade sack of the city. Some believe it briefly went to Athens before being taken to Lorraine, France, where it was exhibited as the burial cloth of Jesus in about 1355 or 1356. The shroud was brought into Turin, Italy in 1578 and has been kept in the Cathedral of St. John the Baptist in Turin since 1694. This is the cathedral where the shroud is kept. This photo was taken in 1978 when the shroud was on display in the cathedral. The shroud is made from linen thread, which is made from the flax plant. The flax plant has long stems containing long fibers. The fibers are removed from the stems by soaking the stems in water until they rot, a process called retting. 100 or more fibers are twisted together to make a linen thread. The shroud is made from hand-woven thread, which probably indicates the shroud was made before the 12th century. A cross-section of the stem of a flax plant shows the fibers in groups around the outside of the stem. Each flax fiber has nodes like bamboo. This allows flax fibers to be easily distinguished from other fibers, such as cotton. This is a photo of the small of the back on the dorsal image at a 32 power magnification. This image shows the 3-to-1 herringbone weave of the shroud and some of the blood that had flowed down from the wound in the side. This shows the tip of the nose at a magnification of 64. The tip of the nose is where the image is the strongest, yet no image can be seen. We only see that in some places the top layers of fibers are discolored with a light sepia or straw yellow color. It is this discoloration on the top fibers of the threads that form the front and dorsal images of the crucified man. The image of the face on the shroud shows large eyes, a long nose, a mustache and beard, and long hair parted in the middle, with the hair a little longer on one side than the other. Notice that the image is an exact front view. This painting is called the Christ Pantocrator, which refers to Christ as the ruler of the universe. It is usually estimated to have been painted about 550 to 600 AD. This painting portrays Jesus with large eyes, a long nose, a mustache and beard, and long hair parted in the middle, with the hair a little longer on one side than the other, with the image being an exact front view. These details are the same as on the previous slide of the face on the shroud. So this painting was very likely made from the face on the shroud. This indicates the shroud was in existence and well known between about 550 to 600 AD, long before the carbon dating of the shroud to 1260 to 1390 AD. The image of the face on the shroud through the Christ Pantocrator painting was copied many times in Byzantine art. The image of the face on the shroud was also placed on Byzantine coins starting in about 692 to 695 AD. This is a gold salatus minted under Justinian II. For the Byzantine emperor to move his image to the back of the coin or take his image off the coin indicates this image of the face on the shroud was well known and revered. This is a bronze Byzantine coin that I own. Experts date this coin to 1025 to 1028 AD in the reign of Constantine VIII. On the left is the image of the face from the Shroud of Turin. The back of this coin, shown on the right, identifies who the image is on the front of the coin. It identifies him as Jesus Christ, King of Kings, in capital Greek letters. These early coins also contradict the carbon dating of the shroud to 1260 to 1390 AD. With all the previous information as background, I will now turn to the issue of solving the mysteries of the shroud. The three main mysteries are: how were the front and dorsal images formed on the shroud? Why did samples from the corner of the shroud date to 1260 to 1390 AD? And why is blood that would have dried on the body now on the shroud, since dried blood does not soak into cloth? The methodology for solving these mysteries needs to be carefully considered. The first requirement for solving the mysteries is to reject naturalism. Naturalism is a philosophy that assumes we are only allowed to use the laws of physics as they are currently known to solve the mysteries. This philosophy of naturalism should be rejected because 1. Naturalism cannot be philosophically proven to be true. 2. Scientists should be open to new ideas and new evidence, even if it is beyond or outside of our current understanding of the laws of physics. 3. In 122 years of research on the shroud, whenever naturalism is assumed, it has never produced an image of the face that is consistent with the face on the shroud, both macroscopically, that is large scale, and microscopically, that is small scale. And 4, an assumption of naturalism would not allow the possibility that the images on the shroud were made by Jesus' dead body in a unique event. Rather than assuming naturalism, we should follow the evidence where it leads. As each scientific evidence from the shroud is considered, we should ask the question, what would have caused this? We could call the process reverse engineering from the evidence back to the cause. This is the right approach to solving the mysteries of the Shroud of Turin. Now we need to determine the scientific evidence that has been discovered on the shroud. I'll break this down into 4 periods. From Segunda Pia's first photograph in 1898 up to 1974 might be called the period of the old masters. These individuals had PhDs, excellent experience, high positions in academia and practical application, and sometimes spent decades researching the shroud. Their study of the pristine appearance of the blood on the shroud brought them to conclude that the dead body of a crucified man had been wrapped in the shroud, and that the blood on the shroud had come from his body. They could not explain how the images were formed. The next period, 1975 to 1987, started when John Jackson, professor of physics at the Air Force Academy, discovered that the two-dimensional images on the shroud contained three-dimensional information from which a statue could be derived. No painting or photograph contains three-dimensional information. This startling discovery led to the founding of the Shroud of Turin Research Project. Acronym is STURP, S-T-U-R-P. STURP in 1978 was allowed to send 26 American scientists to Turin to do non-destructive testing on the shroud over a 120-hour period. I'll discuss the results of that testing in the next slides. The next period of research, 1988 to 2016, started with the carbon dating of the shroud to 1260 to 1390 AD, which is a 2 sigma or 95% probability range. This appeared to prove that the shroud could not be Jesus' authentic burial cloth. This significantly decreased interest in and research on the shroud. The next period, 2017 to the present, started when the British Museum finally released the details of the carbon dating. Detailed statistical analysis of this measurement data, published in 4 peer-reviewed journals, proved that the carbon dates were heterogeneous. This means that the distribution of the carbon dates was not consistent with their uncertainties, so that the measured dates probably included a systematic measurement error or bias. so that the carbon date range of 1260 to 1390 should be rejected, that is, given no credibility. This is a photo of the STURP researchers planning the experiments to be performed on the shroud. The main objective of STURP's experiments on the shroud was to determine how the image was formed. However, what they discovered was that the image could not be due to paint, dye, or stain for multiple reasons. There was an insufficient amount of pigment in the fibers to form an image. There was also no binder to carry the pigment, no brush strokes, no clumping of fibers or threads, no stiffening of the cloth, and no cracking of the image along the fold lines. The shroud also showed no evidence of capillarity, that's soaking up of a liquid, so the image could not be due to application of any liquid. The image could not be a scorch from contact of a hot object with the cloth, because the image did not fluoresce under ultraviolet light, and the image could not be a photograph due to the lack of light-sensitive chemicals on the shroud. As a result, after 120 hours of scientific examination, STURP concluded they could not determine how the images were formed. STURP discovered other things that are very significant. The discoloration on the fibers that form the images is caused by a change in the atomic structure of the atoms that were in the fibers, so that the discoloration on the fibers is not due to the addition of any material, substance, or atoms to the fibers. Specifically, each carbon atom has 4 electrons in its outer orbit, so each carbon atom in a fiber was normally attached to 4 surrounding other atoms by one of its outer orbit electrons. These are called single electron bonds. It was found that in the very thin discolored region of the fiber, some of the single electron bonds were changed to double electron bonds, so these carbon atoms were then attached to only 3 surrounding atoms, as shown in the diagram. Such a carbon atom, when hit by a photon of light, will vibrate differently when attached to 3 rather than 4 surrounding atoms. As a result, it will emit light at a different frequency, so we will see the reflected light as a different color. STURP also discovered that only fibers in the top 1 or 2 fiber layers of the thread that were facing the body were discolored in a thread. The fibers internal to the thread were not discolored. A flax fiber is usually about 15 to 20 micrometers in diameter, which is about 1/5 the diameter of a human hair. STURP also discovered that a discolored fiber was only discolored to a depth of less than 0.2 micrometers around the outer circumference of the fiber, which is only about 2 or 3% of the radius of the fiber. What could discolor only this thin outer region of a fiber and discolor only the top fibers facing the body, both on the cloth above the body and on the cloth below the body? This thin discolored region goes entirely around the outer circumference of the fiber over most of the length of the discoloration. All discoloration has the same light sepia or straw yellow color. The inside of the fiber is not discolored. What could cause such thin discoloration on the fibers? I will now discuss my hypothesis for explaining the 3 main mysteries of the shroud, starting with how the front and dorsal images were formed on the shroud. This is mystery number 1. 3 things are needed to form the image: a mechanism to discolor the fibers, 2, energy to drive the discoloration mechanism, and 3, information to control the discoloration mechanism. Consider a photograph of a person. When a camera takes a photograph of a person, the information that defines the appearance of the person must be carried, transported, or communicated to the camera on photons of light. A photon is the smallest unit of light energy. The colors, shades, and positions that define the person's appearance are communicated to the camera by the frequency, intensity, and direction of the photons of light. Photons of light will reflect off the person in all directions, including some photons that go to the camera, thus carrying the required information to the camera. This information that defines the person's appearance, colors, shades, and positions, is recorded in the camera and later transferred to the pixels in the photograph. This information is then carried from the photograph to our eyes on reflected photons. When the photons hit the rods and cones at the back of our eyes, the information in the photons is translated into electrical signals that travel up our optic nerves to our brains. Our brains have learned to interpret the information in the electrical signals as the appearance of the person in the photograph. Thus, the key is information, both the location and the modes of transport. The same is true for the Shroud of Turin. We can see the image of a crucified man on the shroud because the information that defines the appearance of a crucified man has been encoded into the pattern of the discolored fibers on the cloth. Except in this case, the color information has not been encoded. Only the information regarding the shades and positions has been encoded into the pattern of the discolored fibers on the cloth. This information had to be transported from somewhere else and then be deposited on the cloth. Where could this information, shades and positions, that defines the appearance of a crucified man have been located? It was not located in the air in the tomb or in the limestone floor, walls, and ceiling of the tomb. This information was only inherent to the body. This is true because an observer would only have the mental perception of seeing a crucified man if he looked at the body and not if he looked at the limestone. Thus, an earthquake or nearby lightning strike that caused radiation to be emitted from the limestone could not carry the required information to the shroud. The information that defines the appearance of a crucified man could only be transported from the body to the shroud. Therefore, something must go from the body to the cloth that can carry this type of information, and it must deposit this information on the cloth in a way that can produce the good resolution images that are on the cloth. Waves in a medium, such as sound waves, spray it out, so are not able to deposit focused information. Random processes, such as diffusion of molecules, also spread the information out, so are not capable of producing the good resolution images on the shroud. Photons of electromagnetic radiation, such as infrared light, visible light, and ultraviolet light, can carry such information, as discussed above, and they can deposit this information in a focused manner since each photon travels in a straight line in the direction in which it is emitted. Photons of electromagnetic radiation are normally emitted in all directions from a hot object, but this type of emission could not form the good resolution images on the shroud. But photons of electromagnetic radiation can also be emitted in only one direction, as in a laser. Subatomic particles can also carry information and be emitted in only one direction, as in a particle accelerator. Since the front image that was produced on the cloth above the body is a vertical projection upward from the body, and the dorsal image that was produced on the cloth below the body is a vertical projection downward from the body, it is hypothesized these images were formed by radiation emitted vertically upward from the body to form the front image, and vertically downward from the body to form the dorsal images. Such radiation cannot have been emitted in all directions, but must have been emitted essentially vertically collimated, both upward and downward, to form the good resolution images that are on the shroud. This vertically collimated radiation was probably not emitted just from the surface of the body, but was probably emitted within the body because bones can apparently be seen in the image. And this radiation was probably emitted homogeneously in the body, since complete images of the front and back of the body are on the shroud. More information on these topics can be found in my papers number 5 and 6 on the research page of my website, shroudresearch.net. The nature of the discoloration mechanism will now be analyzed by following the evidence where it leads. The result discussed below is a bit complex, but this complexity follows from the uniqueness of the evidence discovered on the shroud. Evidence number 1. What would cause only the top fibers facing the body to be discolored? This condition is like lightning from a thundercloud hitting only the tip of the lightning rod. Thus, it is hypothesized that the fibers facing the body are acting like miniature lightning rods from which a static discharge takes place. This discharge can also be called an electrical discharge or corona discharge. What would cause such a static discharge from the top fibers facing the body? This could result from vertically collimated radiation emitted from the body, especially if the radiation were primarily charged particles, though electromagnetic radiation such as infrared light, visible light, and ultraviolet light could also have been present. Evidence 2. What would cause this discoloration to have a light sepia to straw yellow color, like a scorch from a hot object? This would result if heat were deposited in this region to bring it to a high temperature. Evidence 3. What would cause the discoloration in a fiber to be less than 0.2 micrometers thick all the way around the circumference of the fiber? This would result if the heat discussed above were deposited only in the 0.2 micrometer thick region around the outer circumference of the fiber. To prevent a thicker region from being affected by the high temperature, the heat must be very rapidly deposited in this 0.2 micrometer thick region and then quickly dissipate by conduction to the inside of the fiber and convection to the surrounding air. What could have caused such rapid heat deposition in only this thin region around the outside of the fiber? It is well known that, due to electromagnetic effects, an alternating current in a conductor will cause the electrons to travel near the outer radius of the conductor, and that the thickness of this electron flow will decrease with increasing frequency of the alternating current. If the frequency of an alternating current in a fiber is high enough, the electron flow and thus the electrical heat deposition will be primarily in this very thin 0.2 micrometer layer around the circumference of the fiber. What would cause such a high-frequency alternating current in the fibers facing the body? If the vertically collimated radiation burst from the body were oscillating between vertically up and vertically down directions with a high frequency of oscillation, it would cause a high-frequency alternating current in the fibers, which would produce a high-frequency static discharge from the top fibers facing the body, both on the cloth above the body and on the cloth below the body. Evidences 2 and 3 could possibly also be satisfied by the static discharge from the top fibers facing the body, producing molecules in the air, such as ozone, which would chemically attack the outer region of the fibers. This is a possible explanation if it produces a light sepia to straw yellow color in the thin discolored region in the fibers. Evidences 4 and 5. The front and dorsal images on the shroud are negative images, with light and dark areas reversed. These images are 2D images on the shroud, but they contain 3D information regarding the vertical distance of each point on the cloth from the body. Both of these evidences result from the fact that the burst of radiation, when it exits the body, will decrease in intensity due to scattering and absorption in the air, and possibly decay for particles. When the radiation is absorbed on the cloth, this decrease in intensity will communicate to the cloth the vertical distance between the body and the cloth, which is the three-dimensional information. It is thus hypothesized that the images were produced by an extremely brief, extremely intense burst of vertically collimated radiation emitted from within the body. The radiation that formed the images was primarily charged particles, was probably emitted homogeneously in the body, and was probably oscillating with a high frequency between vertically up and vertically down directions. This radiation burst caused static discharges from the top fibers facing the body, which caused electrical heating and/or a chemical attack by ozone to discolor the very thin 0.2 micrometer layer in the fibers, which produced the images. Mystery number 2, the carbon dating of the shroud in 1988 will now be considered. The samples for the carbon dating were cut from the corner of the shroud to the left of the front image if it is placed vertically. The samples were cut from an area next to where a section of the side strip had torn off, probably due to handling at some unknown time in the past. This allows the backing cloth that was sewn to the shroud to be seen, as in this diagram. Samples A1 and A2 were sent to the dating laboratory in Tucson, Arizona. Tucson was sent 2 samples so that approximately the same mass could be sent to each laboratory. Sample A2 was not carbon dated but was placed into a vault for later possible use. Sample Z was sent to the dating laboratory in Zurich, Switzerland. Sample O was sent to the dating laboratory in Oxford, England. Each of these laboratories cut their sample into subsamples so that 16 subsamples were carbon dated. Results of the 1988 carbon dating of the shroud were published in the journal Nature in 1989. The average carbon date from the 3 laboratories was reported to be 1260 AD plus or minus 31 years, 1 sigma. When this value is corrected for the changing concentration of carbon-14 in the air, a range of 1260 to 1390, 2 sigma, is produced. The 2 sigma range of 1260 to 1390 indicates there should be about a 95% probability of the true value being within this 1260 to 1390 range. However, there is good evidence the uncorrected value of 1260 plus or minus 31 should be rejected, that is, given no credibility, so that the corrected range of 1260 to 1390 should also be rejected. One reason for this is that the carbon dates from the 3 laboratories did not agree with each other within their uncertainties. A chi-squared statistical analysis of the data indicates there is only about a 1.4% chance that the distribution of the carbon dates is consistent with their uncertainties. This indicates that a systematic error or bias was likely present in the carbon dates. This systematic error was a function of the distance from the bottom of the cloth, as shown in this figure. The y-axis in this figure is the carbon date obtained from the laboratories, and the x-axis is the distance from the bottom of the cloth. The 3 points are the average values from the 3 laboratories, and each vertical bar shows the 1 sigma uncertainty. 1 sigma means there is about a 68% probability that the true value falls within this range. A constant 1260 date, indicated by the black dashed line, only passes through one laboratory's carbon date, but misses the other two. The red slope line is a much better fit to the data, with a slope or gradient of about 36 years per centimeter. How is this slope in the experimental data to be explained, since it is unlikely that the uncertainties in the carbon dates is the correct explanation? To explain this slope in the experimental data, nuclear analysis computer calculations were run using MCNP. MCNP stands for Monte Carlo N particle, where N stands for neutrons. This software was developed at the Los Alamos National Laboratory over several decades and is approved for general nuclear calculations by the U.S. Nuclear Regulatory Commission, NRC. MCNP was used to model a man wrapped in a linen cloth laying on the back bench or shelf in a limestone tomb as it would have been designed in first century Jerusalem. In these computer calculations, neutrons were emitted uniformly or homogeneously throughout the body, since the radiation burst had to occur throughout the body to produce the full front and dorsal body images. MCNP then calculated the resulting neutron distribution in the tomb, and thus the distribution of neutrons absorbed in the trace amounts of nitrogen in the shroud, and thus the distribution of new carbon-14 produced in the fibers that would have shifted the carbon date forward. The results are shown in this slide. The y-axis is MCNP's predicted carbon date that would be experimentally measured. The x-axis is the position in centimeters along the center line of the dorsal image on the section of the cloth that was below the body and the tomb. The curve is quite variable and shows a maximum carbon date of about 8,500 AD for a point under the center of mass of the body. The carbon date to the future, such as this, is calculated when the ratio of carbon-14 to carbon-12 is higher in the sample than exists in our surroundings. The curve in the diagram is normalized to the three laboratories' average value of 1260 AD at the second point from the left, which is where the samples were cut from the shroud in 1988. The amazing thing to realize is that the slope of the curve at this second point from the left is in close agreement with the slope of the carbon dates measurements by the three laboratories, about 36 years per centimeter in the previous slide. This indicates that the slope of the experimental carbon dates, as a function of the distance from the bottom of the shroud, can be explained by the distribution of the neutrons in the tomb that results from neutrons being homogeneously emitted from the body. This is part of the basis for the neutron absorption hypothesis. This hypothesis says that if neutrons were included in the burst of radiation that caused the image, then a small fraction of them would have been absorbed in nitrogen-14 in the shroud to produce new carbon-14 atoms in the fibers. An atom of nitrogen-14, when it absorbs a neutron, would kick out a proton and thus change to a carbon-14 atom. These new carbon-14 atoms would cause the shroud to be carbon dated younger than its true age. It also can explain the distribution of the 16 subsample dates measured by the three laboratories and the carbon date of about 670 AD obtained for the sudarium of Oviedo. The sudarium is believed to be the face or head cloth that was placed over Jesus' face after his death. It is referred to in John 20, verse 7, and is located, we believe, in Oviedo, Spain. This is the only hypothesis that explains these four things: the carbon date, the slope, and the distribution of the 16 subsample dates for the shroud, and the carbon date for the sudarium. Thus, it is the most likely hypothesis to be true. Mystery number 3 is the blood. Experiments have determined that what looks like blood on the shroud is blood. This blood has also been shown to be consistent with human blood, though further experimentation is needed to exclude some other possibilities. There may have been some open wounds in the body that would have allowed blood to drain directly from the body onto the cloth. But the mystery is the blood that would have dried on the body, such as blood that ran down the arms from the wrist wounds and the blood from the scourging. Since dried blood does not soak into cloth, why is the blood that would have dried on the body now on the cloth? The answer is that the burst of radiation from the body that formed the images and shifted the carbon dates, if it was sufficiently brief and sufficiently intense, could have thrust the dried blood off the body onto the cloth. This would have happened when the blood was hit by the particles in the vertically collimated radiation burst. This would have transferred momentum from the particles to the dried blood, thus causing the blood to move vertically upward onto the front image and vertically downward onto the dorsal image. To summarize, the radiation burst hypothesis explains the three main mysteries of the shroud: image formation, carbon dating, and the blood that would have dried on the body. According to this hypothesis, the front and dorsal images were formed by a vertically collimated radiation burst from the body that caused a static discharge from the top fibers facing the body, which caused electrical heating and/or chemical attack by ozone that discolored the fibers to produce the images. The 1988 carbon dating of the shroud to 1260 to 1390 is explained by neutrons in this radiation burst that produced new carbon-14 on the shroud that could have shifted the carbon date forward by thousands of years depending on the location on the shroud. And the fact that the blood that would have dried on the body is now in the shroud is explained by the very brief, very intense burst of radiation from the body that could have thrust the dried blood off the body and onto the cloth. This explanation of the three main mysteries of the shroud is called a hypothesis. A hypothesis is a proposed explanation for a phenomenon that is not fully understood. A good hypothesis has two characteristics. It is consistent with what is known to be true about the phenomenon, and it makes predictions that can be tested. If the hypothesis predictions are proven to be false, then the hypothesis is false, at least as stated. But if the predictions are proven to be true, then the hypothesis gains in credibility. It should be noticed that scientific testing can never prove a hypothesis to be true in an absolute sense. If multiple predictions of a hypothesis are proven to be true, then the hypothesis may gain credibility to the point where scientists believe the hypothesis is true beyond a reasonable doubt. But scientists should always be able to revise their concepts when better ideas or newer evidence becomes available. The radiation burst hypothesis is a good hypothesis for three reasons. It is consistent with the scientific evidence from the shroud because it is derived from this evidence, such as discoloration of only the top layers in a thread, the discoloration being light sepia or straw yellow color, and the discoloration on a fiber being less than 0.2 micrometers thick, and is consistent with the images on the shroud being negative images and the images on the shroud containing three-dimensional information. Secondly, it makes predictions that can be tested. This needs further development. And number three, it is the only hypothesis that explains the three main mysteries of the shroud: image formation, carbon dating, and the blood that would have dried on the body. Thus, considering the current status of scientific evidence from the shroud and the current concepts that have been proposed to explain this evidence, I believe the radiation burst hypothesis is the most likely hypothesis to be true. When we look at the face on the shroud, it is natural to ask the question, who is this? This question is the ultimate application of this study. There are two criteria that must be satisfied to properly answer this question. Criterion 1. This is a man that died by crucifixion. Criterion 2. His dead body, in some way, probably by emitting a burst of vertically collimated radiation, produced front and back images of itself on the Shroud of Turin. If we search all our historical documents, there is only one man and one event that satisfies these two criteria: Jesus Christ in his resurrection. We should be willing to follow this evidence where it leads. Thank you for your attention. I invite you to send your comments to me.